Hi everyone, I'm Priscilla. I miss you guys at the club. I miss science. I miss the lab. So today, let's do a quick experiment to explore the concept of osmosis. And to do that, I'm gonna use water beads. I love these. They're pretty cool to play with. One of the things that makes them so special is that they have this membrane that lets water in and out, but doesn't let a lot of other things in and out, which is very similar to the membranes of our cells. Our cells are separated from the extracellular space by the cell membrane, and the cell membrane lets a few things in and out without, any hassle, and other things a little bit more hassle. So one thing that our cells and water beads have in common is that water can move freely from the inside to the outside and the other way around. So I don't have any dehydrated water beads with me right now, but feel free to Google to see how they look like. The way that you get full plump water beads is by just leaving them in water. So there's something inside this water bead that attracts water. So water moves from the outside to the inside and make them squishy. And that happens through osmosis. So we're gonna play with osmosis and I'm gonna try to shrink these boys. Now, of course, I could shrink them by just leaving them in a paper towel for a few days, I guess. I've never tested it, but I don't have patience. I want them to shrink soon. So I'm gonna put these water beads in a medium that competes with whatever is inside of them for the water. That's my cat eating food. What I'm gonna use is salt. My hypothesis is that if I put these water beads in salty water, they're gonna shrink because the salt is gonna compete for the water, and basically, because of osmosis, the water inside the beads will leave to try to decrease the concentration of the salt outside of the beads. Cool. So how am I gonna do this? I got some cups. I got some cups and some salt. And I'm just gonna make some salty water. I'm gonna put 1 tablespoon of salt, more or less, in this cup. And then in the other cup, less salt. I'm gonna put 1 teaspoon of salt. Cool. And then in this cup, I'm not gonna put any salt. I'm just gonna leave it as tap water. And then here I have some water. And I wanna make sure I have the same amount of water in all the cups. And the only difference, the only variable is the salt. So let's get some water. Let's just put 1/4 of a cup of water. I feel like that's not enough. 1/4 of a cup, 1/4 of a cup. Okay, I'm just gonna do this. I'm gonna add more, 1/4 of a cup of water. Just to make things more interesting, I'm gonna color code them. Brazil. I'm gonna use Brazil colors. Label so I don't forget. And yeah, okay, before we put the water beads in these cups, I'm just gonna quickly measure them, a ruler. But like, they all kind of have similar sizes. So I'm just gonna randomly measure 3 of them. Whoa, this is actually hard. 3/4. 3/4? Yeah, 3/4 of an inch. This one has a little bit less than 3/4 of an inch. This one has a little bit less than 3/4 of an inch. The diameter of these beads are all in between 1/2 inch and 3/4 of an inch. So I'm gonna write that down. I'm gonna put 4 beads in each cup. 4. Ooh. There's already something interesting happening. So, the water beads in here, in the cup without any salt, they are in the bottom of the cup. Do you see that? Here are the beads. Bloop. Whereas, the water beads in the salty water are floating. Now that has nothing to do with osmosis. And I'm gonna leave it as a cool question for you to try to answer. Why are the water beads floating in salt water? And what I'm gonna do is I'm gonna leave these cups like this for 2 hours. I'll write down what time it is right now and come back to you later. All right, cool.